we present Transcendence, a tool for generalizing input to web forms and extracting information from the resulting pages. Our first example demonstrates the steps in our system. The user selects the form field they want to generalize by right-clicking the field and selecting Generalize. It is then added to the pane on the left. The user can input one or more values for this field, and the user can do this with multiple fields. In this case, the user would like to check for flights from 2 local airports to 2 airports near their destination over several days. After specifying the fields to generalize, the user submits the form and waits for the site's result page to be displayed. The user can then click on one or more elements from the results page that they would like to collect. In this case, the user has selected the price, the time it takes to reach the destination, and the flight time of the return. This data will automatically be collected for each of the flights on the page, and for each of the inputs specified in the previous step. Once the user has named the resulting fields, they click Extract, and all the information is automatically collected by the system by issuing multiple queries to the form. Once the results are collected, they are displayed within the context of the site's results page. The user can sort the data in place or visualize it externally. By clicking through the interface, they are presented with a visualization tool displaying the names of the fields they generalized and the fields that were collected. In this example, the user selects a scatter plot and specifies that the price should be shown on the x-axis, while the time there and back should be plotted as 2 series on the y-axis. By clicking the Generate button, the visualization is displayed, giving the user additional insight to help with their ticket purchase. In this example, we show how our system can help plot geographic data, specifically store locations. The user begins by selecting the pull-down menu for the state and generalizing it. The user can then click the Generate More button to automatically populate the list with all the possible values for the menu. The user can view the collected values and remove those that are not valid. But this is not necessary. As before, the user simply submits the form to reach the site's results page. The user can then select the items they would like to collect, in this case the store name and the zip code, which will be collected for all stores displayed in the list on each results page. The user can then extract the results for every state by clicking Extract as before. Again, we see all the collected data displayed in the context of the site's results page. After proceeding to the visualization step, the user not only has the option to view the data as a table, but because the collected data contains address information, specifically zip codes, these can be geocoded and displayed using Google Maps. In this final example, we show how our system can automatically generate a large number of inputs for form fields. Here we have the online directory for our university. The user selects the search field for generalization. The user then enters 3 common surnames into the field: Smith, Johnson, and Allen. By now clicking the Generate More button, we utilize the Know-It-All tool to find and collect similar items from the web. This results in a list of 10,000 potential names and takes about 23 minutes. The user can then tell the tool to collect the names and email addresses from the results page and can now perform the extraction. So by inputting only 3 common surnames, we were able to extract over 50,000 names and email addresses from the directory.